I didn't. Okay, Jess, go for it.
My brain's not firing all cylinders today, but
That's okay.
I thought you wouldn't get anything, but I might be crazy.
Why do you think we wouldn't get anything?
Because your numbers are outside of the block that you already did.
Okay, cool. I like that thought. Like our numbers here are outside of the method. Yeah, so we're thinking about scope. Great. Let me call on someone else to sort of expand on this. Who is making eye contact with me? Let's see. Everyone's looking away from their computer. Amanda, would you like to expand on what Jess started with?
Sure. Well, I guess because the method is calling the numbers, you are listing the numbers below, so I think it'll actually print double of each number.
Oh,
So
it might
2, 4, 6, 8, 10.
Cool, might actually print double of each number. Great. Yeah, so what Amanda's saying here is we're creating this numbers variable. We're sending this variable into the method when we call it. And so this is sort of like, if I make this big arrow, we're sending it in. So this, let's see, this numbers right here is actually referring to the argument that we sent into the method. So Jess, I like your thought where it's like, okay, I created this variable outside the method. So by default, I shouldn't have access to that array inside my method. And in fact, I don't actually have access to this numbers array in the method. I have access to this numbers array in the method. It's sort of funky because I've actually called this the same thing. But if I called this parameter nums instead, the variable that I would have access to would actually be nums. So maybe that makes it a little more clear that those are two different variables. So yeah, Amanda, I like that thought. We're sending in numbers. We're like doing the doubling. So maybe we'll get the doubles printed. Does anyone have any more thoughts on what this might print out? Yeah, Blake.
Not confident on what it's going to print, but I had a question
Yeah,
about
go
what's
for it.
there. So you use numbers plural, and then you have inside of the method or in your block, you have number.
Yeah.
Right. So would that be a problem in that they're not, because your numbers 1 through 5 is plural, and that's going in. And so you do 1 through 5 each do number, I guess, because it's not plural. Does it have a meaning?
So just a reminder, let me grab a different color here. So keep in mind that our block variable refers to a single element. So when we use each, we're iterating over a collection, in this case, like numbers or nums. And as we iterate, we need to call that element. We need to like have a label or a variable for that one element that we're iterating on. And we're going to call that single number. We'll keep hitting on this point as we go through today. Michael, did you have a question, or do you want to add on to what we think this is going to print out?
I have a question, and I can also
Great.
say what I think it's going to do as well. I was curious about some block variables. I run into when I'm writing, and I run into like I need to write a block variable. I end up kind of sitting around, and I'm thinking like I'm in like a creative writing puzzle where I'm trying to like name it appropriately. Can I just name it VAR every time and just like move on? Or
I would not. I think you should name things what they are. So the standard for naming block variables, or the convention, is name it the singular of whatever the collection is. So if it's numbers, if the collection is numbers, the singular of numbers is number. If the collection is people, the singular of people is person. If the collection is dogs, the singular is dog.
Okay. Yeah, that makes sense.
So hopefully you don't have to think too hard about that, but that's the general convention.
Yeah.
Cool. And then
Okay.
do you want to talk about what the return value, or sorry, what this will actually print?
Yeah, I think it's already been said, but yeah, each element in the original numbers array is going to be times by 2. So 2,
Cool.
4, 6, 8, 10 should be
Okay.
the return value. For the,
Okay, so we've got 2 votes for the return value being the numbers doubled. Marla, did you want to add to that?
I actually have a vote in a different direction, and I'm not sure if it's me understanding it correctly or not, but I think
I like it.
dot each returns the original array, if I remember
That is
correctly.
correct.
So I
That
think
is correct.
It's going to print the original array and not the array times 2.
Yes. So each returns the original, wow, I cannot spell, collection, or array in this case. And the return value of a method is always the last line of code run. So our last line of code, or our last little chunk of code here, is this each, which is going to return the original array. So what we're actually going to see printed to the terminal is the array 1, 2, 3, 4, 5. Each returns the original array. Everyone say it together. Each returns the original array. Each returns the original array. And let's see, so each. And the return value of a method will always be the last line of code executed. So in this case, each is really like the last method that we're calling, and it stops getting called. It like finishes its execution at this end. And so each is the last thing we call. And so that is what gets returned from the method. Okay. Michael, did you have a question?
Yeah. Oh, sorry. I guess I was unmuted the whole time. Yeah, I'm realizing now. So if you did put doubles underneath end in the method, then that would be the return value of that, and you would get the new thing, right?
Yes. So if we sort of change this method to have my pen, have doubles returned as the last line, or have doubles as the last line of the method. Now this will actually, when we call print doubles, now we will actually see the array 2, 4, 6, 8, 10. So because each returns the original array, that's why we like sort of need this idea of like some sort of like placeholder or accumulator. The reason that we need this is to capture what we're doing in the block. So the thing we care about is this like number times 2 bit, and we actually need to capture that in the placeholder and return that placeholder as the return value of this method in order to actually see that effect take place. Because what does each return? The original array. I would write this down somewhere. You will get eached at some point in your Mod 1 experience. Dane, go for it.
Yeah, would you mind just repeating just like the specific definition of accumulator slash placeholder?
Yeah, so let me say something else, and then maybe I'll try and define it. So this doubles problem that we're trying to get, what we're trying to do really is get a new array with all the original elements doubled. So that's sort of the pattern or the problem that we're trying to accomplish here. We want a new array with all the original elements doubled. Because each returns the original array, in order to get a new array, we need to create the new array first and then fill it with all the things that we need. So the placeholder is the new array that gets filled with the doubles. So when we use each, if we need to capture whatever we're doing in the block, we need a place to capture that function or that method call, or not method call, but we need a place to capture that change, that determination, whatever it is. And so that's where the placeholder comes in. We're using this to capture what we actually care about as part of the iteration. Did that answer your question? Okay.
Yeah,
Let's
it
go.
did.
Okay, great. Let's go Blake and then Antonio.
You may have just answered it, but I just want to clarify. So like in the doubles shovel numbers times 2, why do we use the shovel instead of like an equals there?
Yeah, so if we had doubles equals number times 2, when we iterated through the first time, what would happen is we would set this array, and instead of being an array, now it would actually be, let's see, what's 1 times 2? It would actually be a 2. And then the next time around, it would be 4. And then the next time around, it would be 6. So if we were setting our doubles equal to that calculation, it's going to reset the variable equal to whatever the like execution of that code is. So instead of adding integers to our array, we're getting rid of the array entirely and just making it equal to a specific number. Does that answer your question? I lost you on my screen.
It's better. It's better.
Okay. So because we want, what we want is this new array. So we need to create an array and fill it with things, not create the array and reset it. Let's go to Antonio and then Catherine.
Yeah, so the doubles empty array that we've created at the beginning of the method, could you similarly take that out of the method and like, let's say have that above and reference, and then I guess when doubles is referenced in the numbers each, would it be referencing that variable outside of the method?
No.
And in that case, it wouldn't, you would be kind of recreating the original array?
So I'm going to take this in 2 parts. So if I had doubles created outside the method, so doubles equals empty array out here, I would not have access to it inside the method. It's out of the scope of the method. Now, if it were an instance variable, then I would, but I'm not going to go down that path at the moment.
Okay. And then I guess just for the sake of explaining this out loud, if you don't mind. So in this, we've created a method called double, which takes an argument numbers. And then within that method, we've created another variable doubles that's an empty array that we want to put values into. And then I think the numbers each obviously is going to take whatever value in the array and then do something to it. In this case, double the number. And then we had to add the doubles at the end so that it basically prints out, well, returns the array again after we modified it, even though running this wouldn't necessarily print anything out unless you do a print of the method. And then I guess the very last line, when you have print or p double numbers in parentheses, that numbers is referencing the variable just at like the line above.
Yes.
Okay.
Yes. Yeah. So the reason that we need to return doubles, or excuse me, the reason that we need to put doubles as the last line of the method is because we want this method to return the doubled numbers. If we didn't have this here, if we just stopped with each, the return value of the method would be the return value of the each call. And what does each return, Antonio?
The original value, the original array.
The original array. Yeah. So
Okay.
numbers, this numbers array is not changing at all. If we wanted to like return the numbers array at the end, we could do that and it will still be the same array that we sent in to the method originally. Numbers is not changing. We are only changing doubles. Catherine.
So I was looking at my solution to the warm-up bounce letters, and did you want like it all in a string in an array, or did you want it just in a string? I was a little confused about what was wanted.
I just wanted it to like print each letter to the terminal. If you want to send me the code that you have, or if you've already sent it to me, I can leave some comments on it.
Okay, thank you.
All right, it is 10:36, 10:37 now. Let's go ahead. Let's see, what is my next slide here? Oh, yeah, okay, we'll do this and then we'll take a pom. So we can use each to solve really any iterative problem. So, and when I say like any iterative problem, pretty much like anything, 99% of the things that we need to do with collections is like, I need to do something or make some determination about every single element in this collection. And we could use each to accomplish all of those tasks. There are some very common iterative problems or iterative tasks that come up in programming over and over and over again. And so Ruby's actually given us some better tools, some better methods to handle these very specific types of problems. And that those methods are called enumerables. Am I writing? No, I'm not. Enumerables. And we're going to learn about three new enumerables, or three enumerables right after our pom. Catherine, did you still have did you have a different question?
No, I just forgot to take it down.
That's okay. All right, cool. So let's go ahead and take a pom. It's 10:38. We'll come back at 10:43. Come back at 10:43. Come back at 10:43. Okay, once again, for the recording, enumerables tackle a specific iterative problem or a specific iteration pattern. There are a lot of enumerables that Ruby gives us. We are not going to cover all of them in mod 1, but we are going to cover a few. And today we're going to talk about 3 of the most common or like most useful enumerables. The first is map. So map is a method that you can use to when you need to create a new array with every element from the original array. Sometimes this pattern is referred to as transform. Why am I? Oh, it's because I'm on the eraser. Sometimes this pattern is referred to as a transforming pattern. We are taking one array. We want a different array that is all of the elements from the original array transformed in some way. So take one array, do something to all of the elements, and put them into a new array. So let's take a look at an example of this. So here's an example of this transform pattern using each. So this is what we were looking at before. What we have here, well, this is slightly different because we don't have it wrapped in a method, but what we have here is we've got this numbers array, and we want to get all of those numbers doubled. So we can use each to do the calculation, send that doubled number to our new array, and fill in our new array as we iterate over our numbers array. Okay, so super common pattern. Map helps us do this in a slightly cleaner way. So if I scroll down here a little bit, now you can see both the each example and how we would do this with map. So with map, we no longer need a doubles accumulator. We can actually capture our doubles by using the return value of map itself. Okay, so here's the first big difference between map and each. Map returns a new array. So map returns a new array. And the way that map works is very similar to each. So the syntax looks pretty similar. Map does take a block. So we start with this do and end. Let me grab a different color here. We start with this do, and the block goes to the end. And what happens with map is map captures whatever we do in the block and sends it to a new array. Okay, we don't have to create the new array. Map is sort of doing that for us in the background, so that this block gets sent to a new array. And when everything is done, when we've mapped through all the values, now our new array can be printed out. Okay, so this is doing the exact same thing as the right side, or excuse me, as the left side with each. Okay. Questions on this so far? As we learn new enumerables, the syntax for all of these is going to be mostly the same. We call the enumerable, in this case, map. We give it a block with do and end. And we set up a block variable that will refer to each of the elements inside of our array as we iterate over it. So as we map over this numbers array, the first iteration, our number is going to be 1. And then at the second iteration, our number is going to be 2. And at the third iteration, our number is going to be 3. So this number will keep changing based on where we are in the iteration, based on what point we are in the original array. Okay. Let's see. Oh yeah, so the syntax is going to be largely the same for all of these enumerables. The most important thing though is this return value. So map returns a new array. It's going to have the same length as the original. And all of the elements are going to be the like original, the OG elements transformed in some way. And how are they transformed? By what we do in the block. So this is the transformation that we want to capture. Okay. All right. I would love for each of you to send me a DM in Slack with what does map do in your own words? In your own words, what does map do? Send it to me in Slack. Great. Awesome. All right, cool. Getting lots of great words coming in. Jacob, did you have a question?
Yeah, if you wanted to just return part of that array, is there a way to shorten map, or is it always going to be the full array?
It's always going to be an array of the same length as the original. So if you need to get an array that is a smaller size, map is not going to be your friend. Yeah, great question. Yeah, so map is going to be, yeah, this like new array with every element from the original array transformed in some way. So it'll be the same length. Yeah, great. Awesome. All right, cool. Let's do some practice. Wait. What? There we go. I just have a duplicated slide. Love it. Okay, great. So we're going to do some practice. So I'm going to send you into some breakout rooms here in a moment. And what I would like you to do is we've got this method, Kennedy Brothers here, and I'm going to drop this in your Slack in just a second. I can get to my notes here. So I'd like you to, in your breakout rooms, rewrite this method using each. And I'm going to put this image into Slack. Why is it not working for me? Copy, paste. Ugh, come on. Copy.
Question.
And yes, go for it.
You said rewrite it doing each, but it's already in each. Did you map?
Sorry, I meant
Or am I
map.
crazy? Okay.
Yeah, I meant map. Okay, well, this is not working for me at the moment. Give me just a second and I will get this into your Slack. And then we will start doing this. Why is this not working? I don't know. Just to frustrate me. That's why it's not working. I guess I'll just take a screenshot of that. Okay, here we go. What the heck, Slack? You are really driving me crazy. There we go. Got it. All right, cool. So send that to your Slack. It's in that enumerables thread. And so I am going to create some breakout rooms. Let's take 10 minutes for this. And I'm going to put 2 people in each room, create those. So let's take 10 minutes for this. And then when you come back together, I'm going to ask some folks to share out your code. Okay. Any other questions on what I'm asking y'all to do here? Okay, I will see you in 10 minutes. Okay, now I am recording. So what I would love is to have one of the groups share the code that they've been working on. Is there a group that would like to be brave and share some code on the screen to the cohort? Let's go with Jacob. Jacob, why don't you go ahead and share your screen?
Alrighty. So here is my code.
All right, cool. And walk us through what y'all have done.
So pretty similar to the each function, we
I
have
think you are
our
muted.
array. Oh, let's see here.
Perhaps.
I can hear you.
Can you hear him?
We can hear.
Yeah,
Yeah, I can.
not
hear
on mute.
also.
Yeah, I
Who am
can
I
hear.
looking at? Where am I looking? Oh, I'm looking at Jacob. I forgot we had two Jacobs. I'm so
Oh,
sorry.
I'm sorry. Yeah, my
But I
bad.
also, for
Jacob
some
in
reason,
if
I
you feel
cannot
like
hear
it.
you. Now can I hear you?
No, yeah, I assumed you
Oh
meant
my
the other Jacob
gosh.
because he started sharing his screen.
Yeah. Hey, you want to hear something funny? I have one of those silly new MacBooks. Maybe you all have this as well, that has like the touch screen at the top. And I had accidentally muted my
Right
like
on.
incoming sound. So that's that's a fun time. Okay, so I have no idea what y'all have been talking about, so I'm gonna assume it was amazing.
It was.
Okay.
All right. Sorry, Jacob. We'll figure out how to deal with this better in the future. But here we are. This is our method for the upcase for the Kennedy brothers. We
Great.
took the variable set to the array, and unlike maps, unlike each, we don't have to have a separate variable set to an empty array. So I just took that same variable, set it to our map enumerable. So it's the brothers that are being iterated over. The single brother is getting upcased each time, and we don't have to shovel it in with this enumerable. So it just goes directly into that. Yeah.
Excellent. Let's go ahead, and I'd love to see this run. If you want to bring up your terminal for us.
Okay.
Awesome. Okay, that looks great. Does someone else, I see Antonio's hand up. Antonio, did you have a question or something to add to this?
No, I mean, I guess I was just gonna share ours. Ours is a little different, but more or
Cool.
less the same.
I like a little different. You want to go ahead and share?
Okay. All right. Can everyone see?
Looks good.
Clear enough? So here I basically just recopied everything and grayed out the stuff that we took out, but we more or less kept everything the same. We just removed Caps Brothers, the variable for Caps Brothers, and just repeating the saved version of that, which each would require, and then modified the each statement, which I think up here, brothers.each, and then it has a Caps Brothers. So we just got rid of, we simplified it, and we just said brothers. We called on the variable and just told it to upcase, and then printed out the method. So in this case, it actually just, you didn't need to create a new variable that says Caps Brothers to just replace the array that was there with the new and save the new modification. So I guess when we go ahead and run it, you can see that everything is capitalized.
Yeah, awesome. So this works. So yeah, the big difference here is that you are not setting a variable to hold on to the upcased array. And I want to pull on this a little bit because I think it's an important, an important piece of this. I wonder if anyone could describe why we don't need a variable on line 20. Does anyone want to describe why we don't need that? Scott.
Yeah, so the method will always return the last line of code it runs in the method, and the enumerable method will return the new array, unlike the each method, which returns the original array.
Yes, exactly. So because the return value of map is the new transformed array, we don't need to set it to a variable. We can just use that return value, leave that as the last line of code run. And so now the return value of the method is that mapped array. Awesome. Alex, did you have something to add?
Nope. I just grayed out different parts of ours and finally got the thing to work. And Blake nominated me to share my screen if necessary.
Nice. Did you have something slightly different than what Antonio and Jacob shared earlier?
Only really in what I put the octothorpe in front of, if you'd like to see.
Yeah, let's go ahead and take a look.
Okay, so this is actually the extent of all of what it is up here in the top right here. So we just like grayed out the things that were under each and decided to make it into do. Screwed up right around here on line 13. That was entirely me. Blake was kind and made sure that I didn't put that in there to give a lovely error message, which looks a lot like this down here in the terminal, by the way.
I like it. Yeah, cool. That looks great. Excellent. Does anyone else have any questions or comments or alternate ways that that their groups came up with this upcase Kennedy Brothers method? Yeah, Elliot.
Can you hear me?
I can.
Sorry. So we had the same thing as the other ones, but we also were trying something with the scope where we'd put the definition of the brothers or an argument for the Kennedy brothers outside of the def method. Does that make sense?
Yeah. Do you want to share your screen?
Sure.
Cool.
So this is kind of what it turned out looking like. Or you can also just define the brothers outside of the method, just by kind of doing the same thing that we did for like dot each, but just a little differently, I guess. And then when you run it, you get the upcase version as well.
Awesome. Yeah, so in this case, you're defining the brothers array outside the method, which means that in order to access that array inside the method, you need to send that information into the method with that argument, which you're also calling brothers. I wonder, Elliot, if you could do something for me. Let's change on line 1, let's change that brothers to people. Cool. And before you run this, I want everyone to just sort of like read through this code briefly and see if you can guess what is going to happen when Elliot tries to run this code. So let's think about it for just a second. See if you can guess what's going to happen. And then Elliot, go ahead and run this. Cool. So we get an undefined local variable or method brothers, and this is coming from line 3. So now on line 3, we no longer have access to brothers. What is the variable that we have access to here? Anyone can shout it out. People. Yeah, so now we're calling that argument people. So anything we send into this method, we need to refer to as people. So Elliot, can you update this so that we are calling that map on our people array? Cool. And then let's go ahead and run this. before we change anything else about it. Cool. So this still works. Now, you'll see that like brother is not necessarily a singular version of people, really. So we could change that to be person, might make more sense. We could really change it to be anything we want. So we could make that person, we could make it muffin, we could make it zebra, we could name it whatever we want. And I think someone else had a question about this earlier, I can't remember who, but from Ruby's perspective, we just need to refer to each element in the same way. We set it up as a block variable, and then anything that we need to do to that element, we refer to it with that block variable, whether it's person, brother, muffin, zebra. Ruby doesn't really matter, but for other developers' sake, we want to make things as clean and as readable as possible. Cool. Great, let's go ahead and just run this one more time, Elliot, just to prove that this all still works and I haven't just thrown y'all off course. Great. Okay, awesome. Elliot, you can go ahead and stop sharing. Any other questions about map so far? Alex, is that a question hand or just a past hand?
That was just me removing all the blood from my fingertips. Sorry.
No worries. Any other questions that y'all have about map so far? All right, let's go ahead and take a palm. When we come back at 11:22, we will learn about another enumerable. So come back at 11:22. Just lost my Zoom cam or my Zoom window. Okay, I'm back. All right, it is 11:22. I never paused the recording, so I don't remember to restart. Sorry for all the people who watch this later. Okay, I'm gonna go ahead and share my screen, and we're gonna learn about another enumerable. Yes, share, good, share, share. All right, great. Awesome. So the next enumerable that I want to talk about is find all. And find all is used when you need to get a subset, so a smaller array based on the elements in the original array. So when you need to find all of the elements from an array that meet a certain criteria. So you're looking for all the elements that meet a certain criteria. I guess I didn't write that on here, but we can do that. So elements, where's my pen? There it is. So we're looking for elements that meet a certain criteria. And when we have this idea of like a certain criteria, we're typically thinking about a condition statement. Does an element make a certain condition true? So if we look at this example using each to do this, if we want to get all the odds, we are going to be grabbing a number if that number is odd. This odd question mark will give us either true or false, depending on if the number is odd or not. So this is how we could do this with each. There is one interesting thing here in this example that you may or may not have seen before, and that's this single line if statement. What this single line if statement is doing is it's saying, do the thing on the left-hand side of the if when the right-hand side is true. So we're saying shovel this, actually, you know what? Let me redo this. So this whole if statement is actually this whole line. So it's saying, do this, shovel num into the results if the number is odd, if that is true. So you may or may not have seen a single line if statement before, but that's what this is doing. It's basically saying like, if num is odd, then result, shovel num, otherwise do nothing. So little sprinkle of if statement in this lesson. Cool. So again, this is how you might accomplish this goal using each, this idea that I need to grab a certain subset of a larger array. I want all the elements that meet a specific criteria. To do this with find all, it's going to look slightly different, more similar maybe to map. And so what's going to happen is find all is going to create a new array. So we're going to get a new array. And the elements in that array are going to be the original, like the OG elements, where the condition is true, where the condition is true. So the way that this works is if we're iterating over this array of numbers, we want to find all of those numbers that are odd. So we're going to iterate through, and the first time through, the find all is going to say, okay, is 1 odd? Yes. Go ahead and send it to that new array. Then it's going to look at the next number, which is 2. Is that odd? No, we're not going to do anything with it. Then the next number is 3. Is that odd? Yes. Go ahead and send it to the new array. Then 4, that's not odd, so we do nothing with it. Then 5 is odd, send it to the new array. So we are find all is creating a new array, and it is sending elements from the original array into that new array if they meet a certain criteria. Okay, the key piece here is we're getting a subset. So the new array that we're building is going to be smaller than the original array. Yeah, Blake, go for it.
Is the array understood, or do we need to call it with something?
Is the array understood?
Or like so for example, we had to puts Kennedy brothers in the last one, right? As like a way to print it or to put it.
Mhm.
Will this print something without having to put print or puts?
No, is the short answer to that. So in that Kennedy brothers example, we defined the method. So like def Kennedy brothers, some code, and then end. And then outside of the method, we printed that Kennedy brothers method. So when we do the printing, we actually go execute the method and print the return value. So in this example that I've got here, I'm only defining this method. I'm not printing it anywhere here. If I did print this method, so if somewhere like below this, I'm running out of room here, but if I did somewhere like below this end, print all the odds, it would actually print the array of all of the odds, because find all creates a new array for us, similar to how map creates a new array. And so we don't need like an accumulator, right? We don't need this with find all. Find all creates a new array. And so if I printed this method, I would actually see an array of only the odd numbers. Did that answer your question? Okay, cool. Brian.
So would you then be able to take all the odds as an array name and then like manipulate it that way, like all the odds dot, whatever, shift or whatever I would want to do from all my array method? Okay.
Yep. Yeah. So when you run a method, as soon as that method is run, you can capture that return value like in a variable, or if you want to run that method and then immediately call like dot length on it, you can do that. When you execute a method, you can sort of think about it as if I have like thing dot method, I start with the thing, and once I call the method, I have now I'm looking at whatever that return value is, and I can call whatever I need to on that object.
Okay. So like, for instance, on this all the odds one, if we just wanted the quantity of odd numbers in there, after this code was done after the end, we could just put print all the odds dot count, I think, and then that would just return. Okay, thanks.
Yes. Yep. Cool. Other questions that y'all have about find all? All right. Cool. Let's go ahead and do some practice. Let me drop this into your into that thread that we've been using. And so what I want y'all to do, I'm going to send you back into, I think I'm going to keep you in your same breakout rooms. And what I want you to do here is now write this method or rewrite it using both each and then find all. So I've got the start of a method. I want you to write the method once with each and once with find all. Okay, and the method should return an array of the numbers that are divisible by 3. So in this case, we're looking for 3, 6, and 9. For this, the expression modulo is going to be helpful. So I'll just put that in there. And I think let's go ahead and take, can I get like a thumbs up, thumbs down for the last practice, or for the last like map exercise was 10 minutes. Let's go. It was too long and it was too short. A little bit of everything. I love it. I think we're going to stick with 10 minutes. I think we're going to stick with 10 minutes for this. So let's do 10 minutes, see if we can rewrite this method once with each and once with find all. Okay, questions about what I'm going to have you do? Okie dokie. Let's see. I wonder if I uncheck this allow to return to main session. We're gonna try it. Okay, I will see y'all in 10 minutes. And I would love to hear from, let's do one group. We're running a little short on time, of course. And I think Corinna had some weirdness that maybe we want to take a look at. So I like weirdness more than anything. So let's take a look at Corinna's code.
Yeah, so we kind of stumbled through it at first and got a weird output and are confused on what happened there. And we're able to figure it out. We didn't get to the find all piece of it, but we can.
That's okay. We can work through it together.
Okay. So this is what we started with here for the each function of it. We defined the numbers. We created a new variable for a blank array. And then I have our numbers dot each do, and then shovel it into the new array here. This is what we had first. We didn't have the if statement, and we ran it and got this.
Yeah.
I'm a little confused on what it did there because the math doesn't make sense in my head for that.
Yeah. So what it's doing there is, so first of all, that modulo gives you the remainder, I think.
Okay.
Sure. And so what it's doing with you when you don't have the if statement is it's just going to run that it's going to, so what's the right way to explain this? So because of the way the order of operations works, without the if statement, it's running everything to the left of the double equals first. And comparing that to 0. And because it's an each, there's like, you're not ever going to see that true false value, but it is going to put in numbered modulo 3 into the nums divised by 3.
Okay.
So yeah, so it's yeah, you need the if in there in order to really run that. Yep.
Did that, and then it gave us the expected, I think, output for that. But yeah, we didn't get to the find all, so we'll.
That's okay. No worries. Awesome. Yeah, that looks great though. Cool. I see. Is it Ezzy? Is that how I say your name?
Yes.
Yeah.
I think
Ezzy.
Matt was first though, but
Okay. Matt, do you want to share?
Sure. I think we got that if statement solution pretty well here. Do I have permission to share?
You do.
Okay.
You said,
So
at least.
okay, so we structured it similarly, tried to make it pretty readable. Got if num mod 3 is equal to 0, then we shovel that num into divisible by 3, and then that's the return value. And that's we used p because I wanted it to be nice and pretty in an array.
Yeah.
But when we used find all, it was much prettier, and the result is exactly the same.
Yes.
So numbers.find all do num, and we didn't even need to use the shovel method or an aggregator, and we still were able to get the same result.
Excellent. Yeah. Yeah. So it's so I think for me, when I was first learning about find all, it was really difficult to conceptualize what is happening. And so I really think about that find all sort of holding on to each element. It's like holding on to it, running some condition, saying like, does this element meet this condition? If so, I'm going to send you to a new array. And then it moves to the next element, holds on to that element, runs that condition. If it's true, sends it to the new array. And that new array is sort of happening in the background, similar to map, right? Similar to map, that new array is kind of in the background of Ruby. Awesome. Ezzy, did I say it right? I don't know why I can't
no, you got it.
put that in my brain. Okay. Did you have something additional that you wanted to share?
Not really, but it's pretty much, no, we got it to work, me and JJ. So I could still share, but yeah, I mean, it's pretty much the same as Matt's.
Cool, awesome. Great, yeah, if you got it to work, that is great. So we've been talking about find all. To save on time, we're going to do a little bit of a shorter thing for this last one. If I were to tell you that there is also a method called find, so we're just talking about find all, there's also a method called find. What do y'all think find might do for us? Think about it individually for just a second, and then I will call on some folks to answer that. So if you think you know what find does, go ahead and put your hand up. Cool, love it. Great, let's hear from Jacob M, since I sort of messed up that earlier.
Appreciate it. Well, since it's find versus find all, would it just find the first element that meets that criteria and just return that?
Yes, exactly. So find will get the first element that meets a specific criteria, but it's very similar to find all. So let me oh, I'm not sharing my screen. Of course. Let me go ahead and share this real quick. Share, share my screen. Yep, do it. Okay, cool. So find is going to return an element. So different from map and find all, which both return arrays, find actually returns the element, an element, one single element. And the element that it's going to return is going to be the first element that meets a certain criteria. So in this find me first even, we're going to get a single element, which is an integer in this case. And that integer is going to be the first one that is even. So as we go through, or as find goes through, it's going to start with 1, the first element in our array. It's going to say, are you even? Nope. Okay, I'm going to move on to 2. Are you even? Yes. Okay, I'm going to stop. I'm going to stop iterating, and I'm going to return this 2. So this method would return the single integer 2. So once it finds the first element that meets that criteria, it stops iterating, and it's done. Okay. And we can sort of see what's happening under the hood if we take a look at this each example, where we're iterating over each number, and we are going to stop with this return, with this explicit return, to say, I want to return this number, the first one, if it is even. Okay. What is different about this each example from any of the other each examples we've seen before? Ted, I think Ted had his hand up first. I can't hear you.
See, return number if number even. Okay, so it should return the first even. What was it? Can you repeat that one more time? Because I know it should return the first even.
Yeah, so what's different about this each than any of the other each examples that we've seen before.
So it's returning value. Sorry, I had my hand up for the one before. I'm a little confused on this. I'm honestly kind of confused. Maybe someone else.
That's okay. Let's go to Corinna. Sorry about that, Ted.
You don't have you don't have to have a new array or accumulator.
Yeah.
For this one.
Yeah, there's no placeholder. No placeholder. What? The reason there's no placeholder is because we are going to like hard stop out of this iteration and return this number the first time the element is even. The first time the number is even, we're gonna hard stop. We're gonna just like throw a wrench into the system, just say like, Ruby, stop whatever you're doing, stop right now. This element is what I want you to return out of this method. So just a reminder that return can override, whoop, that's not words, can override the implicit return value of a method. So typically we think about the return value of a method being the last line of code run. And what the keyword return does is it sort of says like, if you get to this point where you execute this return statement, stop what you're doing, the method is over. Whatever we are doing right now, this is the last line. Okay. If you never hit this return statement, if none of the numbers are even, then this method would return the original numbers array. Okay, but this return is what gives this sort of pattern some power. Okay. I would say like in the grand scheme of things, you are gonna be using find all and map more often than find, but it's important, I think, to understand that find is a thing that you could use. And I think the most important thing really is this idea that some enumerables give us something other than another collection. So some enumerables can give us single elements. Some enumerables can give us true or false values. Some enumerables give us like a count of things. So enumerables don't always return another collection. And it's really that idea of the return value with enumerables that that makes enumerables so specialized, right? So enumerables are used for specific jobs. I use map when I need a new array of the same length with all of the original elements transformed in the same way. I use find all when I need a new array of a smaller length with all of the original elements based on a specific criteria. These are very specific problems that I need to solve, very specific tasks that I need to accomplish. If I'm trying to use an enumerable that isn't meant to accomplish the exact task that I am working on, using that enumerable is actually going to be more difficult than using each. Okay, so enumerables are very powerful when used appropriately. We'll be giving y'all feedback on your independent challenges and projects and things like that, where we might say like, okay, this works, but this isn't actually the correct use of this enumerable. And what we're trying to help you figure out is like, when is the right time to use this enumerable? And in determining when the time is right, you often want to think about what is the return value. I think like the key piece of this lesson is just to understand how important return values really are. Okay. One other note that I want to make, let's see, we're not going to do practice. Some enumerables have aliases. really just other names for the same functionality. So you might see some of these aliases throughout your time here at Turing and out in the real world. Map can also be called collect. Find is also called select. Or sorry, find all is also select, and find is also called detect. We use you use collect, select, and detect in exactly the same way as you use map, find all, and find. So instead of like collection dot map do, and then like these are the elements in the collection, do something, you can just replace this map with collect and it will do the exact same thing. So the same word, or two different words, the same method, really. Why do we have these aliases? To be honest, I don't know. You just do. And some folks will tend to use, like, I think specifically, or like the most common is find all and select. That's where you'll see the most, like, probably of these like three alternates, you'll probably see select the most often. Some people like select, some people like find all. I guess is select maybe like fewer characters to type, perhaps. Maybe that's why some people like it. There's no functional difference. They do the same thing. All right, cool. I'm gonna go ahead and stop sharing. We are running up against our time, so I'm not gonna take any more questions, but if you do have questions, go ahead and post them in the thread in the Slack channel and I will respond to them there. The last thing that I want to leave you with is enumerables. Because there are so many, I do think that it is one of the like best opportunities to really dive into the Ruby docs. So I'm going to drop, where did the enumerables Ruby docs go? I'm going to drop these Ruby docs into y'all's channel just so that you have them. I would say that documentation it's a skill to read and understand documentation. And so if you look at these and you feel like, I don't understand anything that is being like talked about in this documentation, that's okay. Y'all are like brand new coders. But the more you read documentation, the easier it's going to be to figure out what's going on. So I just dropped that in your channel. Let's see, what else did I want to say? I think that's it. If you all want more practice with enumerables, there is a whole chunk of the Ruby exercises that works with enumerables. I would get started on those. They will be very helpful. Also, your project will use enumerables. All of your projects will use enumerables. Okay, that is it. If you have additional questions, please do post them in Slack. I will respond to them. I just want to let you go, have some lunch. And then y'all have project check-ins this afternoon. So take a look at the calendar to see when and where you will be for your project check-ins. And we will see you later. All right, thank you.